This is the ASR1000 demonstration for the embedded packet capture feature EPC. EPC is an onboard packet capture facility that allows network administrator to capture packet flowing to, through, and from the device, and to analyze them locally or save and export them for offline analysis by using a tool such as Wireshark. The way this feature works is that when the packet coming into the ASR1000, the packet will be processed by the Quantum Flow Processor, QFP. And the QFP is able to replicate the packet and send them up to a buffer on the route processor. So now let's see the demonstration. So in this demonstration, I have ASR1000 2-X, and we have two interfaces, gigabit 000 and gigabit 001. One is IPNet inside interface, the other is IPNet outside interface. So we're going to use network address translation to demonstrate this EPC feature on the ASR1000 today. Before we start EPC, we have to define the interest packet we want to capture. So first we have to use access list to define the interest packet. So IP access list, the name of the ACL is EPC. I want to permit all the Icmp packet. So in this case, I want to capture all the Icmp packet. Now user can configure the actual packet capture parameters. So you give a name of the packet capture. In this demo, I use mycap. And you can see there are many options with this feature. I'm going to demonstrate the most essential configuration you can use to get started right away. So first, you want to associate the access list EPC we defined already with this monitor. And we want to define how many packets we want to capture. So now let's define there are 10 packets need to be captured. Next, define on what interface we want the packet capture to happen. So in this case, I want to define gigabit 001, which is my IPNet outside interface. And I want to define traffic on both directions to be captured. And we need to define a buffer size. So 10 packet, I don't think we need a big buffer. I just define 1 megabyte. That should be sufficient. Now let's start the capture. Okay, you can see the capture point has been enabled. Now let's send the Icmp packet. So I send the packet from my neighbor router. I'm doing a pin through the box. I'm pinning 99.99.70.1 using a source address of 10.255.254.4. So let's see if my network translation table. You can see the packet is being translated properly. The packet coming in using a source address of 10.255.254.4 and being translated to 201.255.254.1. And now we can stop the capture. and we can export the capture to externally. So the export successfully. We can also show the packet capture locally on the box. We want to see the detailed option. So you can see the packet going out as the address being translated with the source address 201.255.254.1 sent to that destination 99.999.70.1 is Icmp packet, and the packet coming back is reverse the source destination IP and is also Icmp packet. And you can see there are exactly 10 packets in the capture buffer. And this concludes this demonstration. Thanks for watching.